Assalamu alaikum class. Today is our 21st lecture. In previous lecture we have discussed the distance between the parallel line. Today we will discuss a straight line as an intersection of two planes. Straight line as an intersection of two planes, as we already discussed the equation of the plane. So the condition for the plane is given by a1x plus b1y plus c1z plus d1 equals to 0. The other equation of the plane is given by a2x plus b2y plus c2z plus d2 equals to 0. State equation number 1. The system of equations of plane. State equation number 1. Now the system of these equations of planes are said to be parallel if the ratio of their corresponding coefficients a1 over a2 equals to b1 over b2 equals to c1 over c2. If their ratio of their corresponding coefficient is not equal, then we say that the two planes are not parallel. If the two planes are not parallel, then they must intersect, and their intersection is a straight line. Thus, two non-parallel planes represent a straight line given by two simultaneous linear equations which are represented in variables x, y, and z and are known as non-symmetric form of equations of straight line. In order to transform the equation number 1, which is a non-symmetric form, into a symmetric form, we will have to find any two points on both the planes to determine the direction vector of the line. The method is elaborated in example number 15, in which it will be clear to you. For example, a line in R3 is often characterized as intersection of two non-parallel planes, that is, as the set of simultaneous solutions of two linear equations in x, y, and z. Note that if the given two equations of the planes are as we have discussed that these are non-parallel planes, so the sum of these two planes is given by a1x plus b1y plus c1z plus d1 plus k times a2x plus b2y plus c2z plus d2 equals to 0 is again a plane through the line of intersection of these plane. As we have say that a straight line is obtained in as an intersection of two planes. So this is actually the equation of the plane through the line of intersection of these planes for a1x plus b1y plus c1z plus d1 plus k times a2x plus b2y plus c2z plus d2 equals to 0 is a plane and contains all points common to the two given planes. यानी कि ये जो आपके पास रिजल्टिंग इक्वेशन ऑफ प्लेन आई है वो सारे वो कॉमन पॉइंट्स कंटेन करेगा जो कि इक्वेशन नंबर 1 और 2 के प्लेन्स में है, राइट? Now we have an illustration in which we will discuss in detail that show that the planes 3x minus 2y plus 5z equals to minus 2 and the other plane is given by with the equation x minus y minus z equals to 2 intersect. Obviously when they intersect they gives a line and find a symmetric form of their line of intersection. Solution: the given planes intersect since they are not parallel. As the given planes, you can see from the equation 3x minus 2y plus 5z equals to minus 2 and the other plane is given by x minus y minus z equals to 2. The corresponding ratio of their coefficients are not same, which shows that these planes are not parallel. So they must intersect. They are non-parallel planes. Let us choose z equals to 0 in the two equations. Substituting the value of z equals to 0 in the given equations of the planes, and we are left with the equations 3x minus 2y equals to minus 2, and the other equation gives, after substituting z equals to 0, x minus y equals to 2. Solving these two equations simultaneously, we got the unique solution x equal to minus 6 and y equals to minus 8. Hence, the point P1, which depends upon x1, y1, z1 equals to minus 6, minus 8, 0, which must lies on both planes. Similarly, by choosing y equals to 0, you can also take x equals to 0, whatever you like, in order to find out any arbitrary point which defines on these two planes. We find that the point x2, y2, z2 equals to 1, 0, minus 1. This point is given by substituting y equals to 0, so the equations become 3x plus 5z equals to minus 2 and x minus z equals to 2. In solving these two equations, we are left with the point x2, y2, z2, which is equal to 1, 0, minus 1, and it also lies on both planes. The direction vector d for the line of intersection of two planes is given by d x2 minus x1, y2 minus y1, z2 minus z1, which gives 1 plus 6, which is equal to 7, 0 plus 8, minus 1 minus 0, which gives minus 1. So the direction vector is given by d, which is equal to 7, 8, minus 1. Thus, a symmetric form of equation for the line of intersection is given by x plus 6 over 7, which is equal to y plus 8 over 8 equals to z over minus 1. And the journal form and the topic of symmetric form of equations we have already discussed in the previous lectures. Find an equation of the plane which is passing through the line of intersection of the two planes 2x minus y plus 3z equals to 0 and x plus 2y minus 2z minus 3 equals to 0 and perpendicular to the yz plane. So the solution is given by the intersection of these two planes. As you can see that these two planes are not parallel, so the intersection of these two planes gives gives an equation of the plane which represents a line 2x minus y plus 3z plus k x plus 2y minus 2z minus 3 equals to 0 is any plane through the line of intersection of the given plane. This equation can be written as, after taking the common factor x, y and z, the equation becomes 2 plus k times x plus minus 1 plus 2k times y plus 3 minus 2k times z minus 3k equals to 0. Equation of the yz plane is, obviously a yz plane means x equals to 0. So substituting x equals to 0 in equation number 1, so we are since 1 and 2 are perpendicular, we have 2 plus k equals to 0, which gives k equals to minus 2. Substituting the value of k into 1, so the required equation of the plane is given by, which is actually obtained uh, uh, as a line, as a straight line, which is obtained by the intersection of the two given planes which are perpendicular to yz plane. So substituting the value of k equals to minus 2, In equation number 1, we are left with minus 5y plus 7z plus 6 equals to 0. That gives 5y minus 7z equals to 6. Here is an exercise 8.4 which is from the book SM Yusuf. और इस एक्सरसाइज में अभी जितनी भी आपने प्रैक्टिस की है उससे रिलेटेड क्वेश्चंस हैं. होप यू कैन इजीली सॉल्व देम. These are the few links which are related to the topic we have studied today, which will be hopefully helpful to you all.